Higher chemists, could you answer this question that comes up in the SQA higher chemistry exams almost every year? The question is asking why the fourth ionisation energy of aluminium is so much higher than the third. And you can see here there's the first, second, third, and then it takes a massive jump to the fourth. Now, it's not this specific question on aluminium that comes up most years, it's the successive ionisation energy questions in general that come up where they're asking you why a certain ionisation energy is so much higher than another one. And usually in giving the answer, students are really good at giving one of the reasons, but a lot of the time the SQA want two reasons. So let's look at what these two reasons are in the context of the aluminium that we've just been asked about. So we've got this aluminium atom here, and remember ionisation energy is the energy required to remove 1 mole of electrons from 1 mole of atoms in the gaseous state. The gaseous state bit's a little bit relevant here, but we are removing moles of electrons. For the first ionisation energy, when that happens, we'll just say we're going to remove this electron. That then changes our electron arrangement to 8-2, and we now have a positive aluminium ion. So that's after the first ionisation. If we then go and do a second one, we're then going to remove a second mole of electrons, which brings our arrangement to 8-1 and puts our ion at Al2 positive. Then we go and do the third ionisation. We're removing this electron this time, so that brings our electron arrangement to 8 and we end up with Al3 positive. As you can see, we have now lost this initial valence or outer shell, whatever you want to call it, and we now have a stable electron arrangement. The full and stable electron shell mark is the mark that you guys normally get, but this next point is the bit that you normally miss out. So not only are we now going to be trying to remove an electron from a full and stable electron shell, the electron that we're now trying to remove is actually now closer to the nucleus, so it's going to be more attracted to the nucleus. As we know, a greater attraction means more energy is going to be needed to break that attraction. Only is the fourth electron being removed from a full and stable electron shell, it's also closer to the nucleus, so it's going to be less shielded. Both of these things mean that there's a significantly higher amount of energy required to do the fourth ionisation energy versus the third for aluminium specifically. So when you're asked about successive ionisation energy in your prelim or your final chemistry exam, make sure to give both of the contributing reasons to why the energy has a massive jump.